I am going to work through this factoring completely worksheet so that you can not only see the answers but also how I got them. So first up, remember that we always look for GCF first. So starting with the first one, look for GCF. I see a GCF of 5, so I'm going to take out a 5, and that is going to leave me x squared minus 2xy minus 3y squared. So now what I'm going to do is look at what's left. So after I've taken out this 5, now I have a trinomial. So what I need to do is decide, are there numbers that multiply to be -3 that add up to -2? And the answer is yes. That would be -3 and +1. So this trinomial is going to become x minus 3y. Don't forget about the y since we have a variable on both sides. And then x plus 1y, and you don't need the 1, but I'm just writing it just to make the point. So if I were to multiply these binomials back together, I would get that. I won't get this unless I include that 5. So in the end, this is our answer. And if I multiply everything back together, I will get the original problem. So what I did in this was GCF and a trinomial. All right, number 2. First thing I'm going to look for is GCF. So it looks like I can take out a 2 from everything. So that is going to leave me with 5k cubed plus 5k squared minus 7k minus 7. All right, now I'm going to ignore that for just a minute, and I'm going to focus on this. So this has 4 terms, so I'm going to try grouping. So I could put those 2 together and those 2 together. So out of this group, looks like 5k squared, which is going to leave me with k plus 1. Out of this group, I can take out a -7, which is going to leave k plus 1. So I have 5k squared minus 7 and k plus 1. If I multiply these back together to check, I will not get that unless I include the 2 as part of my answer. So there is my answer. And the types of factoring I did here was GCF, and then it was grouping. All right, next one. First thing I'm going to look for is GCF. So both of those can be divided by 10y squared. So if I take out 10y squared, that's going to leave me with 2x squared, 2x squared plus 3. And when I look at that, it's not a difference of squares, so I'm done. And that was just GCF. All right, next one, number 4. First thing I'm going to look for is GCF. I don't see one. So what I do see is a trinomial with a leading coefficient. So this is a trinomial. So when I have a trinomial with a leading coefficient, I am going to come over here and do the big X. So I'm looking for numbers that multiply to be 100, but add up to 20. So that's going to be 10 and 10. So at this point, I really have 3 options. One, I can now make this into a grouping problem. The other thing is I could divide these by the leading coefficient, but I'm noticing that I'm getting the same number twice. So what that tells me is that I can split these up evenly. So 4u squared would be 2u. 5v squared would be 5v, and it needs to be addition, and I have the same thing twice. So that's probably the easiest way to do that one. Moving on, number 5. So first up, I'm looking for a GCF, and I see that both of those can be divided by 3, and they both have x, y in common. So if I take that out, that would leave me with 5xy squared minus 4. All right, well, that is not a difference of squares, so I'm done, and all I could do was GCF. And that's my answer for that one. All right, number 6. First thing I'm going to do is look for GCF. I'm not seeing anything that will go into everything. So now I notice that there are 4 terms, and when we have 4 terms, we'll check for grouping. So we are going to try grouping. All right, so I'm going to group them as they're written. So I'm going to put those 2 together and put those 2 together. So out of the first group, I'm seeing 7n squared in common, which would leave 8n plus 1. Out of the second group, I'm seeing a negative 4 in common, which would leave 8n plus 1. And now I know that one of my parentheses is 8n plus 1. The other one is 7n squared minus 4. And that's it. So that one was grouping. All right, number 7. First thing I'm going to look for is a GCF. And all of these can be divided by 5. So I take out a 5. That leaves b squared plus 8b plus 7. So I'm going to ignore this for just a second. This is a trinomial. So are there numbers that multiply to be 7 that add up to 8? And the answer is yes, 7 and 1. So this trinomial is going to be b plus 7 and b plus 1. But in order to get the original problem, I also have to multiply by 5. So this was GCF, and then it was just a standard trinomial. Number 8, first thing I'm going to do is look for a GCF. And all of those can be divided by 3. So if I take out a 3, that's going to leave me with 4v squared plus 11v minus 20. If I ignore this 3 for just a second, this is a trinomial with a leading coefficient. So what I need to do is come over here and do the big X. Let's see, I don't want to make it too much of a mess, so I'll do it up here. All right, so I'm looking for numbers that multiply to be negative 80 that add up to 11. And this one might be a stretch for you, but keep in mind that if something ends in a 0, it can always be divided by 5. So 16 and negative 5 would give me negative 80 when I multiply, but 11 when I add together. So at this point, I can either make this into a grouping problem or I can do our shortcut. So I'm going to divide by 4. So this one equals 4 and this one is negative 5/4. The way that transfers into my answer into a binomial is this one is just going to be v plus 4. And this one will be 4v minus 5. If I multiply these back together, I won't get the original problem unless I also multiply by 3. So this one was a GCF and then a trinomial. All right, moving right along. All right, so going to number 9. So first thing I want to do is look and see if there's a GCF. looks like all those can be divided by 4. They can't all be divided by 8, so it looks like 4 is the winner here. So I'm going to take out a 4, which would leave 4x squared plus 12xy plus 9y squared. So if I ignore the GCF for just a second, this right here is a trinomial with a leading coefficient. So I'm going to come over here, and I'm looking for numbers that multiply to be 36 and add up to 12. Oops, sorry. So I'm looking for numbers that multiply to be 36, add up to 12, and that's going to happen with 6 and 6. So right now I really have 3 options here. One thing that I can do is to divide both of these by 4. Another thing I can do is rewrite this as a grouping problem. But since these 2 numbers are the same, I know I can split those up evenly. This is a perfect square trinomial. So I can split up 4x squared as 2x, and I can split up 9y squared as 3y, and I know it's the same thing twice. But if I multiply this back together, I won't get the original unless I include the GCF out there in my answer. So this one was a GCF and then a trinomial that had a leading coefficient. All right, number 10. So first thing I'm going to look for is GCF. I don't see one. This is just a trinomial. So I'm looking for numbers that would multiply to be 64 that would add up to 16, and I'm thinking 8 and 8. So that's the same number twice, so I can write it once with a squared, and that gives me a trinomial. Number 11, first thing I'm going to look for is a GCF, and I do not see anything in here. So now I'm looking for numbers that multiply to be 48 but add up to 6. So after you think about it for a little while, you realize it's not possible. And when it is not possible to do anything, then it's prime. If we can do even a GCF, the answer is not prime. The answer is only going to be prime if we can't do anything at all. All right, next up, number 12. So first thing I'm going to look for is a GCF. Looks like all of those can be divided by 2. So that would leave me 4u squared plus 17uv minus 15v squared. So I'm going to ignore the GCF for a minute. So now I'm looking at this, and this is a trinomial with a leading coefficient. So I'm going to try big X. So I'm looking for numbers that multiply to be negative 60 but add up to 17. And this one might not be as obvious, but if I multiply 20 and negative 3, that would give me negative 60 and it would add up to 17. So at this point you have 2 options. You can make this into a grouping question, or we can just divide by the leading coefficient, which is 4. So I like the dividing. So that reduces to a 5. That one can't be reduced. So I'm going to change these into u plus 5, but there is a v on the end because I need to get the v squared. And this one would be 4u minus 3v. But don't forget, we took out a 2 from the very beginning. So in order to get back to the original problem, we need to multiply these 2 parentheses and by 2. So this one was a GCF and a trinomial. All right, number 13. First up, I'm going to look for GCF. And wow, it's quite confusing, a lot going on here, but I'm not seeing anything for GCF. So it has 4 terms. I'm going to try grouping. I am going to group, let's see, I think I'm going to do the 7 and the 14, and then the 6 and the 3. All right, so out of those two, let's see, we can take out a 7p, and that would leave c minus 2k squared. All right, out of those two, I am going to take out, they both have a 3 and a q, 3 and a q. But when I go to look at what's left, this is going to be 2k squared. So I need to take out a negative. So I get a negative 2k squared with a positive c. And those two, they're in a different order, but they do match. So now I know that c minus 2k squared is one of my factors, and then 7p minus 3q is the other, and that was just a grouping question. So that one is just grouping. All right, next up, number 14. So first thing, look for a GCF. I don't see a GCF, so this is a trinomial, so I'm looking for numbers that multiply to be 9 that add up to 6, and that would be 3 and 3, which means I can write it once and square it. So that one is just a trinomial. So if you want to write b plus 3 times b plus 3, that is, of course, okay. All right, next one, number 15. So first thing we're going to do is look for a GCF. I don't see one. I see a trinomial with a leading coefficient. So I'm going to come over here and try the big X. So I'm looking for numbers that multiply to be 60 and add up to 23. Well, this is very similar to the problem right up here. And that is that 20 times 3 would equal 60, but it would add up to 23. So I could do grouping, which is way 1, or I can divide these by 4, and I prefer dividing. That one can't be reduced. This one can reduce to a 5. So I have a plus 5b, because I need a 15b squared. And then this 3/4 is going to become 4a plus 3b. So that one was a trinomial with a leading coefficient. All right, number 16. First thing I'm going to look for is GCF. I do not see a GCF in this problem. I do see a trinomial with a leading coefficient. So I need to come up with numbers that are going to multiply to be negative 144, but add up to negative 7. All right, so this one's probably the most difficult that I would say. And if you just look around and, guess and check, if you multiply negative 16 and positive 9, those two multiply to be negative 144, but they add up to negative 17. That one you kind of have to think about. All right, from here, I can make this into a grouping question, or I can divide by the leading coefficient. That's what I like to do. So this one would reduce by 3, so we get 3 over 2. And this one we can reduce by 2, which would make it negative 8 over 3. So now I can change that into, this one would be 3x minus 8, but we do have a y, so don't forget that. And this one would become 2x plus 3y. So this one was a trinomial with a leading coefficient. So that's my answer there. All right. Number 17. So first thing I want to look for is GCF. Both of these can be divided by negative 3x. If I take that out, it looks like 7y squared plus x. Oh, sorry, 3x. Yikes. When I look at this, I can't factor that anymore, so I'm done. But I was able to do GCF. So remember that it's not prime unless you can't do anything at all. So just because I couldn't do anything there doesn't mean it's prime. I was still able to take out a GCF. All right, last one. So first thing we look for is GCF. All of those can be divided by 3. So if we take out a 3, that would leave 4x squared plus 20xy plus 25y squared. So now looking at this, so I'm going to ignore the GCF for a second. Looking at this, I have a trinomial with a leading coefficient. So I'm going to go over here and do my x. So I'm looking for numbers that multiply to be 100 but add up to 20. Well, I can use 10 and 10. So right now I have 3 options to answer this question. I can use these two 10s to make this into a grouping problem. I can divide these two by the 4 and then use the fractions. However, since these two are the same, I know it's going to be the same binomial twice. So all I need to do is come over here and split this up. So 4x squared can split up to be 2x and 2x. 25y squared would split up to be 5y. And then they do need to be positive so that I get a positive 20 in the middle. And then just remember that I won't get back to the original unless I multiply by 3 as well. So this one was GCF and a trinomial. And there's your answer. So, bottom line, we always check for GCF first. If there is a GCF, you take it out, and then you look at what's left to see if you can do something more. So you're going to look for trinomial, you're going to look for grouping, you could even look for a difference of squares. If there isn't anything, then you're done with GCF. If you can do something else, you're going to go ahead, finish it, and then everything needs to be included in your answer. And remember, we can check all of these by multiplying back together. So if you multiply back together, you need to get what you started with, what the original printed problem was.